Hi everyone, my name is Rashmi and I am here to present our work on verifying determinism in sequential programs. Consider this testing scenario, which is quite common during software development. A developer runs a program on a test suite, it passes and everything looks good. Then at another time, the developer runs the same program on the same test suite, and this time she observes failing tests. This can be confusing. Unexpected non-determinism in the program is a common source for such scenarios. Debugging non-deterministic issues is hard because of the difficulty in reproducing such bugs. In this work, we focus on the problem of non-determinism in sequential programs. The most common sources of non-determinism are when a program iterates over a hash table and expects a deterministic iteration order. The use of date and time functions or accessing system properties such as the file system or environment properties are some of the examples of non-deterministic sources besides coin flipping. Let's consider an example from a real-world project as an illustration for a non-determinism bug. This is code from Randu, which is a test generator. The method getTypeParameters, shown at the top of the slide, creates a hash set with some values. It then creates an array list out of this set and returns it. The toString method, shown at the bottom of the slide, calls getTypeParameters and passes it to the join method, which returns a string of the list elements in the given order separated by a comma. The specification for toString method is that it should be deterministic. But this specification is violated because getTypeParameters is not guaranteed to return a list that has the same iteration order across executions, since it is constructed from a set. So the code in getTypeParameters is unsafe and could result in non-deterministic program output. The high-level goal of our work is to provide a way for programmers to specify determinism properties in a program, a tool that can verify these properties statically and soundly. A consequence of our sound approach is that if the tool doesn't report any warning, then the program is guaranteed to have no non-determinism bugs and it will have the same output across executions. I would like to note here that our approach permits non-determinism where the specification allows it. For instance, there could be internal non-determinism with the use of hash tables in a method that tests membership. We provide a type system based solution to the problem. In this approach, type qualifiers express determinism properties. We define type well-formedness rules that restrict collection types. And we present enhancements to polymorphism to help improve precision of our approach. This slide shows the overall workflow of our approach. Our tool called the determinism checker takes a program that is annotated with type qualifiers as its input. If the program type checks, then it is guaranteed to have no non-determinism. Otherwise, the checker reports determinism errors. As mentioned earlier, type qualifiers express determinism properties in our approach. A non-det type represents values that might differ across runs. A det type represents values that are guaranteed to be the same across runs. Det is a subtype of non-det as shown by the subtyping hierarchy on the right. We define a third type, order-nondet, that represents collections containing the same element across runs, but whose iteration order might be different across runs. For example, a hash set consisting of deterministic elements is an order-nondeterministic collection. Next, we take a look at the Wellformedness rules for collections. We consider determinism to be a deep property. This means that if a collection has the type non-det, then so do its elements. And similarly for order-nondet and det collections. So, Wellformedness rules do not allow element types to be supertypes of collection types. For example, an order-nondet list of det elements is a valid type, but a det list consisting of non-det elements is invalid because the element type is not a subtype of the collection type. The approach described thus far is sufficient to prove soundness guarantees. The next part of this talk describes how we improve precision by enhancing polymorphism. A polymorphic type expresses multiple overloaded definitions. For instance, calling list.get to access an element from a non-det list returns a non-det element. Accessing an element from a det list at a det index returns a det element. These facts can be expressed by a polymorphic type, which is called polydet in our type system. The polymorphic type, however, cannot precisely express the fact that accessing an element from an order-nondet list returns a nondet element. To express this fact, we introduce a polymorphic variant, polydet up, that is similar to polydet except that it treats order-nondet as nondet. Up is indicative of the subtyping relationship of order-nondet to nondet. We also define 6 other variants to polydet, and you can find more details in our paper. We now present the results of applying our tool, the determinism checker, on our case studies. These projects shown in the table are open source and are actively maintained. Our tool reported a total of 87 determinism bugs. These are locations where the programs diverge from their determinism specification, and most of these issues were fixed by the developers after we reported them. This goes to show that non-determinism is hard to find and that our tool helps discover important bugs. Now, since ours is a compile time approach, it produces false warnings. We wrote a total of 753 warning suppressions. When we studied these warning suppressions, we found that the most common reason was code that implemented order insensitive algorithms. The code on this slide shows one such example from our case studies. Here, type.getDeclared fields returns an order-nondet collection, and iterating over it results in nondet elements of the field type. But since the code in the for loop is searching for a particular value, the method always returns a det field, and the method is safe. Many of the warnings in this category would be eliminated by using list comprehensions introduced in Java 8, but these legacy programs didn't use those features. We also wrote annotations at code locations where the specification diverged from the default types applied by our approach. These annotations also serve as machine check documentation, and they help find issues that the developers could not. Next, we discuss work that is closely related to our work. Nondex is a state-of-the-art approach for detecting flaky tests. The authors of that work manually identified 25 JDK methods that are known to be non-deterministic and built models for them that would return a different result each time they are invoked. This approach requires modifying the JVM so that any test calling one of the non-deterministic methods calls the wrapper method instead. Deflaker is another tool that detects flaky tests. It uses version control history and the test suite to identify non-determinism. At a high level, a test is flaky if its output diverges across versions, even if there is no difference in its code coverage. Both these are runtime approaches. They have found bugs in real-world projects. However, they cannot provide any soundness guarantees. We compared the determinism checker to Nondex and Deflaker by running it on the case studies of these tools, and were able to find all bugs that are not related to concurrency. This is an advantage that Deflaker has over our approach, that it can detect concurrent bugs. We also found additional bugs in check style that the previous tools did not. When we ran Nondex and Deflaker on our case studies, they couldn't find any of the bugs that we did. In summary, we make these research contributions. Ours is the first sound compile time analysis of non-determinism. We designed a type system for expressing and verifying determinism properties. We provided enhancements to polymorphism that improve expressivity. Our tool found determinism bugs in real-world projects, and it is publicly available and is open source. Thank you.
Okay, everyone, hello, and welcome to those of you who have just joined us in this last Q&A session of Blended Sessions Room 1. Welcome back to those of you who have already followed the first two presentations of this session. So I would like to welcome Rashimi. She is a PhD student at the University of Washington. Thank you for your presentation. Now let's go with the questions. So just reminding everyone again, type your questions in the chat. We already have a question from Na. So she's asking, is there any scenario where the tool can produce false positives due to the limitations of static analysis?
Yeah, that's a great question. So yes, this is a static analysis tool, and there are going to be false positives. And the most common scenario where we observe false positives is places where the iteration order doesn't matter. For example, if you have a list that is, let's say you have a hash set that's order non-deterministic, and all you want to do is just iterate over it and copy it over to um, another hash set, or um, create a list that you also expect to be order non-deterministic. Um, um, Basically, all locations where order didn't matter. And another example would be someone iterating over a hash set just to search for an element. The element is always going to be deterministic in that case. So because we decided that iterating results in non-deterministic elements, doesn't mean that the final result is always going to be non-deterministic. So that's one place where I think more refinement would help. But yeah, there are going to be false positives. Yes.
Okay, so thank you for your question. Sorry, for your answer. Thank you now for your question, and thank you, Rashimi, for your answer. So in the meantime, that someone else writes maybe questions, I would like to ask you a question myself. So in your experiments, your tool has been applied in open source projects, which are actually actively maintained. Have you done any experiments on industrial projects that are not open source projects? And if you haven't, do you intend to, or do you expect any kind of very different or any differences in terms of performances or results?
That's a good question. The answer to that first question is no. We haven't tried it on industrial benchmarks, mainly because we don't have access to it. I worked on this project in my university and didn't have collaborations. But the second question is, do I expect any difference in the results or the performance? I don't think there is going to be a difference in terms of performance or the bugs that our tool will report, or the soundness guarantees that it provides. It would largely, the number of bugs and whether they are going to be useful, it depends on what the tool itself, what the benchmark itself or the project itself intends to do. Does it heavily use these collection operations, and is there a lot of code that expects determinism at locations, and it's it's critical for their it's important for correctness, which I believe is most of the times. But yeah, I can't be 100% sure just because I don't have the data.
Okay, so yeah, I know it's more of a like feeling kind of thing. So now asks another question. Can you hear me? Okay.
Yes.
Asking what about the false negatives when there are type parameters used, like generic typing? It can be hard for you to decide whether hash set is passed as a parameter and has all elements enumerated in order. Is that correct? So a comment on the false negatives.
No, the tool will not have false negatives. It is sound. So the question is, when there are type parameters, it can be hard for you to. So the types are assigned even to the type parameters. So you can have an order non-deterministic hash set, which consists of other order non-deterministic hash sets, or you can have. So the types are not just on the outer collection type, but these types are applied to all the nested types as well. I think that was the question, and I hope that answers. So if you iterate over an order non-deterministic hash set, which is a type parameter, you are going to get a non-deterministic hash set. So there is no scope for a false negative there.
Okay, so yeah, I don't see any more comments from now, so I'm assuming that you have answered her question. Otherwise, now I ask you to write in some other question or comments onto this answer. So we have a question from Michele. Can your tool also detect non-determinism that doesn't arise from a direct data dependency, such as, for example, a function that computes and returns the index of an element of a non-deterministically ordered sequential data structure by searching it?
Function that computes and returns the index of an element of a non-deterministically ordered sequential data structure by searching it. So I think what you're asking is if I have a function that returns an index of an element of non-deterministically ordered. So this is again, this I'm assuming this will be a user written function. So in that case, yes, because you are iterating over a non-deterministically ordered data structure. So I'm assuming in that case the user will have to manually annotate the types and specify where they would where they would want determinism. In that case, yes, because you are iterating over a non-deterministically ordered data structure, whatever you iterate on top of it will be a non-deterministic type, according to the tool.
Okay, so I think that answers the question. If you have any other comments, Michele, please add to the chat. Okay, thank you. So I guess you did answer his question thoroughly. Thank you. So your tool of determinism checker, just wondering, does it work for any type of program? Oh, okay, so let me just ask. No, I will ask Nan's question. How about we have foo t where we know nothing about t? It can be an object or any set.
Yes, sure. So you can annotate t as well because it's just any object. So a t will have annotations as well. So every type in our so according to our type system, every type has a type, except that order non-deterministic applies just to collections, which are other than that, everything else will have a type. So yes, t can also have a type annotation.
Okay, so it can be an object or any set, correct? Okay, thank you again. So my question is, does your tool work for any type of program or for only programs that have specific type of characteristics or features?
No, the tool applies to any program. The implementation is in Java currently, but there's no reason why. I mean, it works for any program, any Java program.
It's like, okay, good. So just another very quick questions. Do you see any limitations to the study, to your findings?
So there are a few places where the tool might be overly conservative. For example, if there is non-deterministic branching, or there is information flow that can be more precise when you branch non-deterministically, or take where the control flow is dependent on non-deterministic types. In that case, the tool becomes overly conservative, and it's going to report warnings on all
I need to cut you off.
beyond that. Sure.
So thank you, everybody, and see you next time.